Hello everybody and welcome back to MrMiers Math channel. Today in the rational functions chapter we're going to talk about section 9.5, which is adding and subtracting rational expressions. This section is going to be much more lengthy than the previous two sections. Alright, so let's get into it. Of course we're going to skip some examples as we go, but to start out in example 1 we're going to do each one of these. To perform the indicated operation, remember to add or subtract fractions, we need to have a like denominator. So the denominators need to be the same for us to combine these. All right, it's the same as if we had, 3 halves plus, 5 halves. We could add those because the denominators are the same, and we'd get 8 halves or 4. All right, if the denominators are not the same, we cannot do that. All right, so in part A, we have 3 over 2x plus 5 over 2x, so that would be 8 over 2x. And then we could simplify from there. They both have common factors of 2, so when we simplify and take out that common factor, we have 4 on x. All right, in part B, these have the same denominator, so we can combine them. And then we would have x minus 2 in the numerator. So we have x minus 2 over x plus 3. And remember, this is simplified. To get rid of an x minus 2, we would need another x minus 2 in the denominator. Same thing for the x plus 3. For part C, now we got to be careful with this one because we're subtracting this fraction, right? Which means we're going to be subtracting that whole numerator. The denominators are the same, so we don't have to do anything there. So now this is going to be 6 minus x minus 6 on x minus 1. And then 6 minus 6 is going to cancel out. So what we get left over is just negative x on x minus 1. All right. So let's move on to the next one. All right, we're going to skip 1 and 3 here, and we're just going to do 2. And if we take a look at this, we have x on x minus 2 minus 2 on x minus 2. So they have the same denominator, so we can combine these. And we'll get x minus 2 on x minus 2, and anything divided by itself is going to be 1. So it simplifies to be 1. Awesome. Moving on to example 3. In some of these where they don't have a common denominator, we need to make those denominators the same. So we're going to have to change each of the fractions to get the denominators to be the same. So we don't want unlike denominators, we want like denominators. So we're going to be talking about the least common denominator. We'd use the least common multiple of the original denominators as that like denominator, and that is called the least common denominator, or otherwise abbreviated as the LCD. All right, so let's get into the first one where we're just going to find the least common denominator. One way to find the least common denominator is to look at the multiples. All right, so just looking at 6 and 8 first, we can look at the multiples of 6, which would be 12, 18, 24, and so on. All right, and if we look at the multiples of 8, that'd be 16, 24, and so on. Notice we have a common multiple there of 24. In terms of the variables here, we have x and x cubed. Multiples of x, might be x squared, x cubed, and then we see, boom, okay, that would be a common multiple. So for the integers and the variables, the least common denominator would be 24x cubed. All right, for part B, now both of these are factorable. 2x minus 4 is 2 times x minus 2, and then 3x plus 3 is the same as 3 times x plus 3, but that doesn't really get us anywhere in terms of finding the LCD, because none of these are the same. All right, so when they have nothing in common here, the least common denominator is just going to be the product of those two denominators, 2x minus 4 times 3x plus 9. All right, in part C, we can see that 9 is a multiple of 3 and x squared is a multiple of x. All right, so the least common denominator is just going to be one of the other denominators, 9x squared. And then in part D, we'd have to do some factoring to see this, but x squared minus 4 is that LCD, and that's because x squared minus 4 factors to be x plus 2 times x minus 2. All right, so it already has an x minus 2 in there. We would just have to multiply this denominator, or this fraction, by x plus 2 over x plus 2. All right, so moving on. Now we're going to perform the indicated operation by using that LCD. So notice the denominators are not the same in these two fractions. So we've got to make them be the same. In order to do that, we're going to have to multiply each one of the fractions. All right, so first let's find the LCD. All right, so we have 2 right here, and of course we can multiply this fraction by 2 over 2 to get that common multiple. And then x squared is a multiple of x, so the LCD is 2x squared. So now we need to multiply each fraction so that each one of these says 2x squared. Oops, didn't mean to do that. Just undo it. All right, so to get 2x squared on the left fraction, we'd have to multiply by x over x. Remember, we can't change the value of this expression, so we have to multiply by the numerator and the denominator. So that would change this into 3x on 2x squared. And then to change this into 2x squared, we'd have to multiply by 2 over 2. So we have 3x on 2x squared and then 8 on 2x squared. Now we can combine these things and we'd get 3x plus 8 on 2x squared. In part B, the least common denominator, since they have no like factors here, would be just multiplying by the other denominator. So we could get a least common denominator in that first fraction by multiplying by 4 over 4. And then we could get a least common denominator in the second fraction by multiplying by 5y over 5y. All right, if we do that, we get 16 on 20y minus 15y on 20y. And then we could combine these, and we would get 16 minus 15y on 20y. After we combine, the next thing that we should always do is check and see if we can simplify. And in this case, we can't. All right, let's move on to part D. We're going to skip part C. And then in part D, once again, like before, we're just going to multiply by the other fraction, the denominator of the other fraction, to get that LCD, because that's going to be the least common denominator. So in the first fraction, we'd get 12u on 30u, and on the right fraction, we would get 10u squared on 30u. Now we're going to combine, so we have 12u minus 10u squared on 30u, and we do need to simplify here. All right, if we notice, we have a u in each one of these terms in the numerator and a u in the denominator. So we can cancel out one of those u's. And then also in terms of the integers here, we do have a common factor. That would be a common factor of 2. And if we cancel out that common factor of 2, we get 6 minus 5u on 15. Awesome. I'm just going to go back through part D and simplify it a different way. We could always get rid of common factors right away, and that would simplify this process. So the u's would cancel out in the first fraction, the common factor of 2 would cancel out in the second fraction, and really we have 2/5 minus u on 3. And then to get that common denominator, we can multiply the first fraction by 3 over 3 and the second fraction by 5 over 5. And that would give us 6 on 15 minus 5u on 15. And then we could combine that, and that would be a little bit easier way to simplify this problem. All right, so now let's go on to part E. All right, so another way to find the least common denominator is basically see what each one of the denominators have that's missing from the other. So if we take a look at this first denominator, 3v, what the other denominator has that this doesn't would be a 2, of course, and then also v cubed. So we got to figure out how to get the 2 and the v cubed. All right, so we could multiply this by 2 over 2. And then to get v cubed, we could multiply it by v squared over v squared. And vice versa, if we take a look at what this denominator has that the other one, if we take a look at what this denominator doesn't have that this one does, that's a 3. It already has a v, so all we have to multiply by is 3 over 3. All right, so now let's do that. So 2v squared times 4v, that's 8v cubed. 2v squared times 3v, that's 6v cubed. And then in the second fraction, 2v times 3 is 6v, and then 2v cubed times 3 is 6v cubed. All right, now we can combine these. We have 8v cubed plus 6v, all on 6v cubed. Now notice that we do have common factors amongst the numerator and denominator. 8, 6, and 6, those all have common factors of 2. All right, v cubed, v, and v cubed have common factors of v. So we could take out 2v from the numerator and denominator, and what we would have left over would be 4v squared plus 3 on 3v squared. All right, so 4v squared plus 3 on 3v squared would be that simplified form. All right, we're going to skip F and go on to G now. So in part G, once again, let's just check out what each one has that the other doesn't. So we already have a y, we have a factor of 2, and to get 6, we would just multiply by 3 over 3. All right, in the right fraction, what this one has that the 6y doesn't is the x squared, so we could multiply by x squared over x squared. So if we do that, we get 15x on 6x squared y, and then on the right side, we'd get 4x cubed on 6x squared y. Then we could combine these. And we get 15x plus 4x cubed on 6x squared y. And then also we got to keep in mind, we've got to check for common factors. So we see a common factor of x in the numerator and the denominator. So let's take out that common factor of x, and we get 15 plus 4x squared on 6xy. All right, another method or another approach always is to check out common factors and to simplify right away, and that's another way to eliminate this final step of simplifying. All right, a couple more examples here. If we take a look at 5, if we want to perform the indicated operation, subtraction, once again, we always got to find that LCD. Now, x squared minus 1 is really just x plus 1 times x minus 1. If we would factor this. All right, so this does have an x plus 1 in it. So the LCD is going to be x plus 1 times x minus 1. And that means we just need to multiply this right fraction by x minus 1 on x minus 1. That's what it's missing. All right, so we have 1 on, and I'm just going to write this as x plus 1 times x minus 1 minus x minus 1 on x plus 1 times x minus 1. Now we can combine these, and we got to be careful when we combine these. 1 minus the quantity x minus 1. So we have to subtract both x and subtract negative 1. So that's really 1 minus x plus 1 and then let's simplify that. So 1 plus 1 is 2, so this is really negative x plus 2 on x plus 1 times x minus 1. All right, moving on to example 6. Oops. All right, now this one looks pretty tricky. But once again, to find that LCD, we just got to figure out what one denominator or what both of the denominators are missing. This says 5x times x minus 2. This says 5 times x minus 2. So this one's just missing an x. So the LCD is 5x times x minus 2. And all we have to do to get that same denominator is multiply by x over x on that left fraction. So that means we'd have x squared on 5x times x minus 2 minus x plus 2 on 5x times x minus 2. Now let's combine that, and we get x squared minus x minus 2 on 5x times the quantity x minus 2. And this is factorable. The numerator factors to be x minus 2 times x plus 1, which helps us simplify because now we can see that common factor of x minus 2. So this simplifies to be x plus 1 on 5x. All right, now we're moving on to our last example. This last example is probably the most challenging that we've seen. Now in this last example, it's always helpful to maybe look at the factors. So 3m plus 6 is factorable, and that factors to be 3 times the quantity m plus 2. All right, so what this left denominator is missing is an m plus 2. All right, and then what the right denominator is missing, although maybe it's not apparent, is that factor of m. So the LCD is really 3m times m plus 2. Now let's multiply that. So we get 5m plus 10 on 3m times the quantity m plus 2. And then 2m squared on the quantity 3m times m plus 2. Now we can combine. And I'm just going to write this in standard form. So we'd have 2m squared plus 5m plus 10 on 3m times m plus 2. And that numerator is not factorable, so this is in simplified form. All right, folks, that's it. If you like this, if you found this helpful, please like, subscribe, share. Thank you, and have a great day.